Now, you know that in industries, if you want to find whether the milk is the pure milk or it is mixed with water, we use an instrument called lactometer. It will tell us the purity of the milk, and you can construct that instrument lactometer. Now, I'm going to tell you how to construct it. Take a tube. This is the making of lactometer. Making of lactometer. Take a tube, and it's a tube filled with water. It is water filled with water. Now put a refill. You understand refill? Refill means the refill inside the pen. Refill with his metallic pin inside the water. Now what happened? The refill floats in the water. When the refill becomes stable, then what you do, you just mark on the refill where the surface of the refill touching the surface of the water. So this is the surface of the water. So here this refill touching the surface of the water. So mark it. This is step 1. Now step 2. Again take the same cylinder. Now this time you fill with milk. Again put the refill inside the milk. Again it floats. After when it becomes stable, again see the which part of the refill is above the milk surface, and see, and there you mark it. Now same refill you have taken, and you have 2 marks. Say mark 1, mark 2. Mark 1 representing the equal volume of water surface, mark 2 representing the equal volume of milk surface. Now third step, what I have to do? You mix the water and milk and again pour into the cylinder. Put the refill inside it. Now what is your observation? The observation is that if it is a pure milk, that water, the milk plus water level should be goes to the marker of the milk. If it is full of water, then the surface should touch the mark of the refill. As already told you that water and milk both are mixed. It is neither water, it is neither milk. It is a mixture. Therefore, what happened? The refill floats, but the mark will be between the mark of water and mark of milk. In that way, you can check that what is the purity of the milk. We understand that how to find the density of a substance, density of a liquid. Now, if you think that if you have 2 liquids and both are mixed, now how do you find the effective density of that mixture? And in this mixing also, you have 2 cases. Let us discuss about the first case. Number 1, the mixture having same mass. Suppose water and milk you have taken and mix it. When you mix them, see that water and milk both have same masses. So what happened to the effective density? Let us do the calculation. Okay, so mass of liquid 1 equal to m, mass of liquid 2 is also m because same mass, but volumes are different. Volume of liquid 1 say V1, volume of liquid 2 say V2. Yes, of course, density of liquid 1 is, you see, you can write D1 density. Sometimes density is represented by another symbol called rho. So either D1 you can represent, or you can say rho 1. It looks like S, but it's not S. It is called rho 1. Okay. Now, density of liquid 2, D2, or you can represent with the symbol rho 2. Right. So now you mixed. In mixture, you mix the two liquids in mixture. Total mass equal to m plus m, which is 2m. Okay. Now see here. I told volume of the liquid is V1. According to density formula, we know the density equal to mass by volume. Let me write here. We know the density equal to mass by volume. Implies from that find the volume formula. Take V to the left hand side, bring the D to the right hand side denominator. Then you will get m by d. Now take this formula, supply here. So V1 equals to m by d. Mass is m, but d is d1. So we'll write d1, m by d1. Similarly, V2 equals to m by d2. So in the mixture, total mass you have found. But what happened to total volume? Total volume is V1 plus V2. So V1 is m by d1, V2 is m by d2. So we got total mass, we got total volume. Now what we have to find? We have to find effective density. So effective density, same formula, mass by volume, same mass by volume, but here it is total mass by total volume. So total mass is 2m by total volume, m by d1 plus m by d2. Now in this denominator I can take m common. Then what happens? 2m by, if you take m common, I will get 1 by d1 plus 1 by d2, and m are cancelled. Now equals to 2 by 1 by d1 plus 1 by d2, 1 by d1 plus 1 by d2 equals to, now take LCM, d1 plus d2 by d1 d2, it reverses, so we'll get 2 d1 d2 by d1 plus d2. So this is what the effective density of a mixture. So if you know the density of two liquids, usually you can find the effective density. We have discussed about how to find the effective density of mixture having same mass. Now it's the second case. We are going to find the same effective density of mixture of liquids but with same volume. Now how do you find? Say liquid 1, okay, I'll write like this, volume of liquid 1, which is V, same volume. Volume of liquid 2, it is also V, same volume. When the volumes are same, you should know that masses are different. So mass of liquid is, liquid 1 is m1, mass of liquid 2, which is m2. Yes, density of liquid 1 is d1. I told you earlier you can use rho 1 also. Density of liquid 2 equals to d2. As usual, you know the formula density equal to mass by volume, and this time see masses are different. So from this I will find the mass formula, m equal to volume into density, d into v or v into d, anything you can take. Okay, now let us find total mass of the mixture. Total mass of the mixture is how much? It is m1 plus m2, but m is v into d. So m1 equals to v1 into d1. We have to write like that, but it is same volume, so it is v only. m2 v into d2. So supply the formulas here. V into D1 plus V into D2, total mass. So now total volume of mixture equal to total volume is how much? V plus V, it is 2V. Now effective density, again total mass by total volume. So total mass is VD1 plus VD2 by total volume is 2V. If you observe carefully, in numerator and denominator V is there, so cancel V. So what left with? D1 plus D2 by 2. So if you know the density of two substances or two liquids, just take the average of it, you will get the effective density.